Good morning. Today is May 9th, 2024. Today we are going to continue talking about electrical field. Different from last lecture, we are going to talk about superposition. So in Chinese, superposition means 合成 or 叠加. Okay, so suppose we have 2-point charge in the coordinate system. One is the positive charge, which is located at the origin with the charge of positive 1 nanocoulomb. We also got another charge which carries a negative charge. Again, it's negative 1 nanocoulomb. They both are 1 centimeter apart. Now we want to look at the point right here. Distance, let's label it. This is going to be O or 0. This is going to be point A. This is going to be point B. And then the distance between point B and point O is, again, that's 1 centimeter. The distance between point B and point A, again, is also 1 centimeter. We want to calculate the electric field at point B, that due to the charge at the origin and also charge at the point A. So that's what we're looking for. How do we do that? Okay, so let's just do it graphically. So since this charge at the origin is positive charge, so the electric field at the point B due to that charge will be in that direction, right? Which basically extension of the line right here. Similarly, the electric field due to the charge at the point A is going to be along this line, but the direction is going to be a little bit different because the negative charge right here, instead of pointing outward, is actually pointing inward in respect to this charge right here. So that's point this direction. Since they carry the same amount of magnitude in terms of the charge, and then also the distance are the same. So if we look at the equation Q over R squared, K is constant, Q is the same, the magnitude is the same, the distance is the same. So the value of the E is going to be same. In other words, the size of those two arrows should be the same. In other words, if we try to get a component in the Y direction, those two Y direction components is going to be cancel each other. If we try to get a component in the X direction, then it's going to be twice of each of the X components. So with that being said, let's do the calculation. So first, let's calculate the magnitude in that direction. So E equal K, let's say QO, which means the charge is the origin right here. Absolute value, R squared, is going to be K 8.988 times to the 10 to the power of 9 Newton m squared, which is meter squared over coulomb squared. That's our K. And then we need to times the charge. The charge right here Actually, it's 1 nanocoulomb. So it's 1 times 10 to the negative 9 coulomb. And then the distance is 1 cm. So 1 cm times 1 meter is equivalent to 100 cm, and then don't forget the square. So this 10 to the power of 9 cancel with this 10 to the power of negative 9. So that's the number we have. And then here is 10 to the negative power of 2 squared. It's going to be 10 to the negative 4. But once you flip it, it's going to be 10 to the 4. So the result would be 8.988 times 10 to the power of the 4. Again, this is going to be m squared. Cancel with this m squared. Newton keep it. Coulomb. Cancel 1. So the unit would be Newton over Coulomb. So that value right here actually is this part right here. That E. Okay, now we know the y component of that is being cancelled out. All we need to find is the x component. Since this line is parallel with the x-axis, so the angle right here, that theta, is going to be same as this angle right here. Since those since those 3 lines are exactly the same, based on the geometry, we know this is a 60 degree. So we try to get one component over there. That one component is going to be E times the x component. It will be cosine theta. It will be E times cosine 60 degree. Use the trigger identity. That will be E times sine 30 degree. Right? So that will be equivalent to E times half. We just leave the way it is. And then we know this is just one component due to this. But similarly, the x component due to this electric field is going to be exact same due to symmetry. So indeed, it's the E net in the x direction. That's going to be whatever this part right here is going to be E times half. Since we have two of them, we need a times 2, so it's just going to be E. In other words, the net electric field in the x direction is going to be exactly the same number as C. Now we need to put everything together. So the final result, the electric field at point B, since this is the vector, right, we have to put an arrow over there. We know the magnitude is this guy. It's 8.988 times 10 to the power of the 4 Newton per coulomb. Don't forget this is in the x direction, so we need to put I hat over there. So that's pretty much it. And then we can expand this problem a little bit. For instance, this is a positive 1 nano C, this is a negative 1 nano C. We just calculate right here, right? What if we try to find the electric field in the point C right here? Then in that case, we have to look at the electric field due to this charge. Since it's a positive, so that goes to that direction. And then we also have to consider the electric field due to this charge right here. Since this is a negative charge, the electric field is go that direction. And then we have to do the superposition of those two. Similarly, if there's a charge right here, then the electric field due to the positive charge will be in that direction, and then the electric field due to the negative charge will be also in that direction. So it's going to be a superposition of those two. If the point is right here, then the negative, the electric field due to the positive charge will be go that direction, and then the electric field due to this negative charge will be go that direction. So it's going to be a superposition of those two. One last question. If we got a 1 point right here, for instance, this is not symmetric, right? We have to look at the electric field in this point, let's say it's a point F. Then, first we need to connect this. Then the electric field due to this charge right here will be in that direction. Let's say we call it E, F, O. And then another electric field due to this charge right here, if we connect those two, it's going to be in that direction, right? Because this is a negative charge. Then we call it E, F, B. And then our final result will be a superposition of those two. How do you do that? I think one way you can do is the following. You found the component of the y direction, and then in x direction, so you got one component of each. And then you also found the component of this electric field in x direction and in y direction. You got a second pair. And then you add those two y components, and then you add those two x components. Notice the y components, their direction is opposite of each other. So indeed what you do is a subtraction. But the x direction, the superposition is addition. And then you will get an ex component and an ey component. And then you either combine those two in one vector, or you write down something as I plus j. Okay, so it depends on what your teacher asks for. Again, that's pretty much it for the electric field due to the point charge. Those are just a very fundamental stuff. And if your problem given is more than 2 point charge, all you need to do is follow the exact same procedure. It's just a little bit tedious. You have to do the superposition of 3, 4, or whatever the given point charge are. Starting from next lecture, we're going to be talking about electric field, but instead of point charge, we are going to talk other geometric distribution of those charges, and then it requires a little bit calculus background. So from now on, if you feel your understanding of calculus is kind of shaky, I strongly suggest you to do a little bit review before the next lecture, so that way you will be prepared. Again, thank you again for watching my videos. Please feel free to leave your comments, so that way I can improve. I can speak both Chinese and English. If you guys prefer all English lecture, please feel free to let me know. Or if you prefer all Chinese or combination of both, feel free to let me know. I can do either one of them. I'll just go with the majority vote. Thank you again. Talk to you guys later. Bye-bye.